Good afternoon. So, today I am going to continue to discuss our results on Stieltjes transform. Namely, I am going to discuss some basic properties of Stieltjes transform, and using those basic properties I am going to talk about and solve some application problems. So, let us continue our discussion. So, let us look at some properties of Stieltjes transform. So, the first set of properties shows that the Stieltjes transform of f of t plus a is given to be f tilde of z minus a. So, I am going to, well, the assumption here is that a is positive and a is real as well. Okay. So, to see this result, this has a quick proof. So, if I were to, let us start with the left hand side. So, the left hand side is the integral 0 to infinity f of t plus a divided by t plus z dt. So, then this is also equal to, if I were to make the substitution u equals t plus a, then this integral becomes f of u du divided by, so t is u minus a. So, I get u plus z minus a, and the integral is from, so u equals a to infinity. Now, we note that since a is positive, then we must make sure that z minus a should not be a negative real number, otherwise the Stieltjes transform is not defined, and this was one of the results that I have shown in my last lecture. So, this means that this particular integral is the Stieltjes transform of f at this argument z minus a. Okay. Moving on, well, this particular property I call this as my shifting property, the shifting of the Stieltjes transform. The second one shows that if I am given the function f, then the Stieltjes transformed of the scaled function. So, this is the scaling property is given to be equal to the transform at this scaled new variable. Okay. So, I call this as my scaling property. So, again the proof is rather straightforward. If I use my, to begin with, I start with the left hand side, I get that this is the integral 0 to infinity f of a t divided by t plus z dt. Now, again I make the substitution u is equal to t a, and I see that the new integral is f of u. Now, du dt is du by a times t, which is u by a plus z, and integral from 0 to infinity, and I see that this integral is, after all the simplification, comes back to the following form f of u du divided by u plus z a, and this is also equal to the Stieltjes transform at this scaled variable f at z times a. Okay. So, then I have another result which tells me that the Stieltjes transform of t times f t is equal to negative z times the Stieltjes transform of at this argument variable z plus the integral 0 to infinity f of t dt. As we can see, an initial intuition must highlight the fact that proving this result involves integration by parts, and that is what we will do. So, look at the left hand side here. I have, this is equal to the Stieltjes transform integral 0 to infinity t times f of t dt divided by t plus z. So, then to further solve, I am going to break this integral into two halves. Note that this particular integral is integral 0 to infinity t plus z minus z times f of t dt divided by t plus z. Note that this is also equal to integral 0 to infinity 1 minus z divided by t plus z times f of t dt. So, let us now distribute the function, and the first integral is the integral that we have in our right hand side, namely this particular case. This is from 0 to infinity f of t dt, and the second integral is negative z integral 0 to infinity f of t divided by t plus z dt. Note that the second integral that we have is the Stieltjes transform at the argument variable z, and which gives our answer, which is as follows: f of z f tilde z times negative z plus the integral 0 to infinity f of t dt, and this is what our right hand side of the expression is. Okay, so then there is another property which says that if I am given the Stieltjes transform of f t divided by t plus a, then this is also equal to 1 by a minus z times the Stieltjes transform at the argument variable z minus the transform at the variable a. Okay, so again we start with our left hand side to see that the left hand side is the integral 0 to infinity f of t dt divided by t plus a times t plus z. Okay. So, then as we can see from so far we have done so many examples, we see that the natural choice to move ahead is to use the method of partial fractions, that is, break it down into two partial fractions of this following linear factors. So, I am going to use the method. So, what I have is, this is again let me write this in another page. So, this right left hand side is integral 0 to infinity f of t dt divided by t plus a times t plus z. So, what I have is, this is also equal to integral 0 to infinity f of t dt, and then I am going to break it down into partial fractions. I get 1 by a minus z times 1 by t plus z minus 1 by t plus a. Okay. So, let us check that a minus z, and that should give us the answer. Yes. So, note that this particular factor 1 by a minus z is independent of the integration variable. So, I can pull that out of the integral, and I get the following two integrals: f of t dt divided by t plus z minus integral f of t dt by t plus a. So, this is also equal to 1 by a minus z, and this first integral is our Stieltjes transform at the argument variable z, and the second one is the Stieltjes transform at the argument variable a. Okay, so, moving ahead, what I have is another result which shows that the Stieltjes transform of 1 by t f of a by t is 1 by z Stieltjes transform of a by z. Okay, and again I continue to assume that a is a positive real number. So, then to prove this result, well, to prove, let me again start with the left hand side, and I get this following integral 0 to infinity 1 by t f of a by t divided by t plus z dt. So, as expected, we are going to choose my new variable u to be equal to a by t, because the choice comes out of the fact that this is what the argument of f is, a by t. So, then when I substitute this variable, I have du is equal to negative a by t square dt, or this is also equal to negative u square by a d dt. Okay. So, when I use these substitutions, I get my new integral as follows. So, I get this is integral from infinity to 0 minus a by u square du times u by a times f of u divided by z plus a by u. So, then after doing all the simplifications, well, of course, we have to reverse the integral because of this minus sign as well. So, I get the new integral as 0 to infinity, and then 1 by z times f of u du divided by u plus a by z. Okay. Note that this integrand is nothing but the Stieltjes transform of f evaluated at the argument a by z. So, I get my answer as 1 by z Stieltjes transform evaluated at a by z, which is what my right hand side is. Okay. So, then I have some properties of Stieltjes transform related to its derivatives. So, I state it as a theorem. So, the theorem is related to the Stieltjes transform of derivatives. Stieltjes transform of derivatives. So, what I show here, so the result says that if I am given that the transform of f is f tilde, let me just highlight by saying that I denote my Stieltjes transform of f by this f tilde, then I have two results. The first result says that the transform of the derivative of the function, the derivative with respect to the variable t, is negative 1 by z times f at 0 negative the derivative of the Stieltjes transform of f evaluated at this variable z. And similarly, the second, in fact, we can construct many such statement for each of the derivative of the function. Let me state the general result. So, the general result in this theorem says that the Stieltjes transform of the nth derivative of t of f of t is negative 1 by z f n minus 1th derivative at 0 plus 1 by z square f n minus 2th derivative at 0 and so on, plus 1 by z to the power n f of 0, and the last term is the derivative. So, it is the nth derivative of f tilde with respect to z, the argument variable. So, let me show you the first one, and the general case follows from the first case using induction. So, let us look at the left hand side. So, I have the left hand side as follows. So, this is the Stieltjes transform of f prime given by this integral 0 to infinity f prime of t dt divided by t plus z. So, then I have that this is also equal to f of t by t plus z, and then so I am in evaluating this integral, I am using integration by parts. So, integration by parts. Okay, so again I choose this as my first function and this as my second function. So, first function integral of second evaluated at 0 to infinity minus differential of first function 1 by t plus z square, with a minus sign will give me a plus sign, and integral of second dt. Okay, so, when I evaluate I have that, well, f, the function f must be bounded, otherwise there is no point in evaluating the Stieltjes transform, and if that is the case, the value at the infinity will vanish. So, I have that this first term will give me negative 1 by z f of 0. So, I have assumed here the following condition. So, negative 1 by z f of 0 plus integral 0 to infinity f of t by t plus z whole square dt. Notice, so we note the following, we note that if I were to take the derivative of the Stieltjes transform, let us see what happens. So, this is also equal to the derivative with respect to z of this integral 0 to infinity f of t dt divided by t plus z. So, when I take the derivative I am going to get minus the integral 0 to infinity f of t dt divided by t plus z square. Okay. And we see that this particular integral is nothing but the negative of the integral in this expression, on the right hand side. So, what I have is, so before moving I have seen that on the right hand side I have the following expression. So, the first expression is as it is, negative 1 by c f of 0 negative the derivative of f tilde or the Stieltjes transform with respect to z. So, that is my right hand side. Now, I am going to leave the proof of the second case, because the second case is nothing but the first case repeated n times. So, repeat integration by parts n times to come to the result. Okay. So, this is a hint that I have given to the students, and using this hint the students can very easily derive the second part of the theorem, which is the general case of the nth derivative of Stieltjes transform. So, then I have more results. I have another result in the form, let me just state it in the form of a lemma, which says that if I have a function f of t and f of t has an exponential rate of decay, exponential, I am going to state this lemma without any proof, but this lemma is going to be useful for evaluating certain expressions in our application problems. So, the lemma states that if f of t has an exponential rate of decay as I evaluate the function in this limit, then all moments m r exists, and they are given by the following: m r is equal to the integral 0 to infinity t to the power r f of t dt. Okay. So, all the moments exists and is given by this integral. Then the lemma states that the Stieltjes transform of the function f is of course given by this integral f of t dt divided by t plus x, and this is also equal to the Stieltjes transform at this variable x is given by. So, this is the main part of the result, it is given by this series r from 0 to n minus 1 to the power r m r x to the power minus r plus 1 plus a remainder term which are denoted by epsilon of x, where epsilon of x is given by this remainder term x to the power minus n plus 1 supremum of this following integral from 0 to t tau to the power n f of tau d tau. So, I take the supremum from 0 to infinity. So, the supremum is taken over all values of this upper limit of the integral. So, that is the result. So, then I am going to use this result in the following example. The example says, find the solution of the integral equation given by lambda times 0 to infinity f of t dt divided by t plus x, and this is also equal to f of x. So, I need to solve. We see that the unknown of the problem is the function f. So, f is the unknown. So, the unknown is my function f of t, and I see that f appears inside the integral and outside as well. So, we need to solve this.